Now let's solve using quadratic formula. So I'll write the formula once. I'll put it over here. X equals negative b plus or minus the square root of b squared minus 4ac. Oops. Sorry about that. I wrote an a again. Divided by 2a. It's a little bit of a stretch for me. All right, so in the first one, a is 3. So these are in standard form, which means x squared is first, and then the x term, and then the constant. If it's and then it's set equal to 0. If your equation is not in standard form, you need to get it in standard form first. So a equals 3, b equals negative 5, c equals negative 1. So we have x equals negative 5 plus or minus the square root of negative 5 squared minus, I'm going to run out of space. I hate it when it does that. Minus 4 times 3 times negative 1, all divided by 2 times 3. So now let's simplify. So we have x equals, that's 5, plus or minus 25, there's two negatives, be careful on that, plus 12, all divided by 6. And let's simplify that. X equals 5 plus or minus the square root of 37 divided by 6, and that doesn't simplify. Now, this is so a problem like this would be convenient to use quadratic formula to solve because b here is not equal to, excuse me, a is not equal to 1. And we'd have some interesting fractions dividing by 3. So that one might be a nice one for quadratic formula. But remember, completing the square also has other purposes, like being able to rewrite our equation in vertex form. And number b and c are not too bad for completing the square. So maybe we'll do completing the square with b and c as well. All right, so number 2, using quadratic formula, a would be 4, b would be 12, and c would be 9. So this would be x equals, I'll try to write a little smaller. So b is 12, so it would be negative 12, plus or minus the square root of 12 squared minus 4 times 4 times 9, all divided by 2 times 4. So this would be x equals negative 12 plus or minus, boy, that negative sign. Negative 12 plus or minus 144 minus, so that would be 4 times 4 times 9, so 16 times 9, that's going to be 144. No. Well, instead of using, well, we could use quadratic formula with this one or factoring. So this is going to be x equals negative 12 plus or minus 0 divided by 8. That's going to be negative 12/8 or negative 4/3. So this one was factorable. So let's just take a look at factoring. So a times c, 4 times 9 is 9. 4 times 9 is 36. Two numbers that multiply to give us 36, but add to give us the b term of 12 is going to be 6 and 6. So it's perfect square. 4x squared plus 6x is a group, plus 6x plus 9 is a group. Greatest common factor, we can pull out 2x. We'd have a 2x plus 3. Greatest common factor is 3. Divide both those terms by 3, we have a 2x plus 3. And we can see we have 2x plus 3 squared. So our only solution here is going to be, wait, did I? Oh, I have a reducing error. Since when is 12/8 4/3? They're both divisible by 4, 3 halves. And our answer here is x equals negative 3/2. Let's jump in the gun on the reducing there. So this one could be solved either way. I would think I would always factor if you can factor. Factoring is a very important skill. And then the last one, all right, so we could use quadratic formula, or we could use completing the square on this one. So we have a here is 1, b is 2, c is 2. So we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2, all divided by 2 times 1. So that's x equals negative 2 plus or minus 4 minus, that would be 8, divided by 2. That would be x equals negative 2 plus or minus the square root of negative 4 divided by 2. That's a perfect square. So x equals negative 2 plus or minus 2i divided by 2. Can't leave that like that. Factor out the 2. X equals 2 times negative 1 plus or minus I. And you can cancel the 2's out. So our answer is x equals negative 1 plus or minus I. And in this case, completing the square, oops, it's all caught in there, is actually going to take us less space. Right, if we were to use, I don't know if, let me see if I can squeeze completing the square in here. All right, so we would move the 2 to the other side. So we would have x squared plus 2x equals negative 2. And then we'd add that magical number 2 divided by 2 squared to both sides. Oh, except the magical number isn't fitting. There we go. I think my orientation's a little off on the side there. Well, there's a square there somewhere. All right, there's a square there. All right, so we have x squared. I've got my microphone and about pulled as much as I can. We've got x squared plus 2x plus 2 divided by 2 is 1. 1 squared is 1 equals negative 2 plus 1. On the left-hand side, that would factor to x plus 1 squared, right? Half of b, right? So x, whatever the sign is, half of b, half of 2 is 1, equals negative 1. We can take the square root of both sides. Oops. I'm going to have to extend the page. I'm going to extend the page a little bit. So this is getting a little too cramped. And something to go over here. I can't reach it over there. There. Now we don't have to be that cramped. Equals negative 1. Take square root of both sides. Don't forget plus or minus. Square and square root cancel. This is x plus 1 equals perfect square. Square root of negative 1 is I. Subtract 1 from both sides. X is negative 1 plus or minus I. This one was so much simpler to do completing the square with. I didn't have to worry about having to keep simplifying my radical. And that's the end of these ones. All right, so notice we had one real. So this solution here is real but irrational. Our second solution was just real. What happened to the 2? Is real and rational. And the third one was complex or imaginary. And I guess technically it's complex because it has a real and an imaginary component. So how will we know if we'll get rational, irrational, or complex solutions? Right? Well, we can use the discriminant. The discriminant of a general quadratic equation, ax squared plus bx plus c, is that part underneath the radical, and that's going to tell us whether or not our quadratic equation is going to have real solutions or rational or irrational. So if your discriminative, what's under the radical, is greater than 0, then and this is in your notes, then the equation has two distinct real solutions. If it's a perfect square, then your solutions are rational. And you could have factored. If it's not a perfect square, then the solutions are irrational. And you would have had to have solved using quadratic formula completing the square. If your discriminant is 0, then the equation has exactly one real solution, and that one real solution is rational. And again, you could have factored. If d is less than 0, if the discriminant is less than 0, then the equation has no real solutions, and instead it has complex solutions. All right, so let's take a look at that. All right, use the discriminant to determine how many real solutions each equation has. So we're just not going to solve here. We're just going to determine. Actually, we've solved at least one of them. 4x squared plus 12 minus 12x plus 9. All right, but we'll do the discriminant. So the discriminant, I'll write it up here again, is the square root of b squared minus 4ac. Actually, excuse me. We don't need the square root on that one. Just b squared minus 4ac. All right, so in the first one, a is 1, b is 4, c is negative 1. The discriminant is 4 squared minus 4 times 1 times negative 1. That's going to give us 16. That's two negatives there. That's a plus 4, so that's 20. So we have two real. Now 20 is not a perfect square, so it's going to be irrational solutions. And that's because 20, not a perfect square. Let's try the second one. All right, so we have a equals 4 equals negative 12, and c equals 9. So we have the discriminant is negative 12 squared minus 4 times 4 times 9. And that's going to be 144 minus 144, and that was 0. And so we have one real rational solution. And then the last one, a is 1/3, b is negative 2, c is 4. So discriminant is negative 2 squared minus 4 times 1/3 times 4. So that's going to be 4 minus, so that's 16/3. Right, 4 times 4 would be 16. All right, let's simplify that. So to combine, we need a common denominator, and we need to change the 4, so it's got a denominator of 3. So if we multiply the denominator by 3, we need to multiply the numerator by 3. So 12/3, of course, and that looks a little like r-thirds. 12/3 is equal to 4. So we have 12/3 minus 16/3, that's negative 4/3. So here we're negative, we have two complex solutions. And using the discriminant can be helpful if you want to figure out if an equation is factorable or not, or whether you need to use another solving method. Right? And I think that's it for this video. We have one real life solution, one real life problem. Let's do the real life problem on the next video. So thanks for watching. Bye for now.